Today I will give a brief talk on domain wall. The reference is this very old literature. Let us consider a 5-4 Lagrangian in two-dimensional space-time. The space-time coordinates is labeled by t and z. The Lagrangian is given by this formula. This is the scalar field, real scalar field. This Lagrangian has a Z2 symmetry, phi 2 minus phi. It's easy to see because it's only the even order. And the potential has two degenerate minimum. Phi equals to plus V or minus V. And the vacuum manifold has two-fold degenerates. Let us consider a possibility that one boundary condition at phi equals to plus V at z equals to infinity, and phi equals to minus V at z equals to minus infinity. In this case, the function phi z has to go from minus V to plus V, as z is taken from minus infinity to plus infinity. So it must necessarily pass through the horizontal axis. We can choose the phi cross the horizontal axis at 0 at the original point. Then there is energy in this field configuration if we choose the boundary condition. Since the potential is non-zero when phi is not equals to plus and minus V. When phi equals to 0, then the potential is non-zero. Let us see the code of potential. This part is only equals to 0 when phi, the absolute value of phi equals to V. If phi not equals to V, then it will not be 0. This picture is some example. Also, this configuration cannot relax to either of the vacuum configuration. The vacuum configuration, two vacuum configuration, phi always equals to V, or phi always equals to minus V. And this configuration cannot continuously transform to the two vacuums. Since that will cause an infinite amount of energy, because if we change this configuration to phi always equals to plus V, then we need to move this curve to this part in finite region to the line. So it will cause infinite amount of energy. Another way to see this is to note the presence of a conserved current. This current is a conserved current. It's hold in any two-dimensional quantum field theory. Because if we live in two-dimensional, we can always construct a current. It will be conserved because its epsilon mu is antisymmetric. In this is symmetric in mu. So if this combination is 0. So use this conserved current, we can see the charge, conserved charge. The conserved charge is the space integral of the zero. So we can see this form is depends on the boundary value. For the vacuum configuration, the two points are equal. So this part is zero. So the charge is zero. But for the configuration we consider at this point phi equals v and this point phi equals minus v, then it's not zero. Their difference is 2v. So the charge is 2. So these two configurations has different charge, so they cannot transfer each other continuously. So the configuration cannot relax into the vacuum because they are in different topological sectors. To get the field configuration with the boundary condition of this boundary condition, one will have to solve the equation of motion. The equation of motion is secondary differential equation. We can see what the form of the equation of motion. Using Euler Lagrangian equation, we can get the equation of motion, and this is secondary differential equation. So its explicit form for two-dimensional space-time is this form, the time and the space. So it's not easy to solve this question. One clever method to solve the equation of motion is proposed by the Bogomolny. And if we use this method, we can obtain a first order differential equation. The method uses the energy function. We can easily get the Hamiltonian of this theory, and this part is the Hamiltonian. So the Hamiltonian and integrate over the space coordinates, we get the energy. And it has three parts. We can combine the last two parts to get a quadratic form. And this is the cross term. We can see the cross term after integrate is only depend on the boundary values. So if we get the boundary value of the field fixed, then this is fixed by the boundary. So and the other two terms are quadratic terms, so they are non-negative. So if we want to minimize the energy, we need to these two terms to be zero. So the condition is these two terms to be zero. And the minimal value of the energy is the cross term. Is determined by the boundary values. Let us see these two conditions. We can use these two conditions to get the solution, kink solution. In our case, the potential is this form. We can get this combination as this. So if we insert this term to the equations, we can get the kink solution. This solution. It is very easy. It only involves an integral hyperbolic tangent this function. Then we can easily get and this we can get some integral constant. The z equals to 0 when phi this is arbitrary. If we have another like z0, then modify this to z minus z0. Okay, but it's not important. For the kink solution, we get the minimal energy, and the minimal energy is given by this value. This value. We can easily solve it because the boundary values are fixed, and it's only determined by the boundary values and the potential function. And then we get this very easily to get this result. And we can also express the results by the mass of the kink. The mass of excitations of phi in the vacuum, we can easily get the mass as this result. We can choose the wave as phi equals to V and let the field as the excitation of around the vacuum. So we can get the mass term of the excitation. We compare with this term and this terms, we can get the mass this result. So now we can re-express the minimal energy by the mass of excitation. We can see the minimal energy is proportional to mass to 3 order, the third order. Although this model is discussed in 2-dimensional, we can extend it to 4-dimensional case. We can consider the case when phi only depends on z, but not on x and y. So the field configuration only depends on z, and every x and y they are degenerate. So it like a wall. So it's called domain wall because in x and y dimension they are like a wall because the field condition only depend on the z. So we can also obtain the kink solution for every value of y and z because the solution is not dependent on x and y. So the solution like in 3 space like a wall in xy plane is identical to z axis. So it's the main wall.